You just gave my secret away. Now, there's no need to write any of this. This is just me putting it on the board so you can see it. Boyle's law. What did Boyle compare? Volume and pressure. And what did it look like? All right. P1, V1 equals P2, V2. And then we had, say, Gay-Lussac. Lussac. Just not even close to being right, but you get the idea. Gay-Lussac. What did he compare? Oh, sure. Let's be. Yesterday was Charles' law. What did we compare yesterday? So volume and temperature. So that means that Gay-Lussac compared pressure and temperature. Okay. So, and they teach us some things. Now, Boyle's law says that if pressure goes up, volume has to go down. Gay-Lussac said if pressure goes up, temperature goes up. And then if volume goes up, temperature goes up. And in every scenario that I've given you over the past 3 days with each law, we've only dealt with two variables. But in the real world, pressure, volume, and temperature are always fluctuating. What's fluctuating mean? Changing. Okay? And so the question would be is, what if pressure goes up and the volume also goes up? Well, what happened to the temperature? We'll see. Okay? These only happen. Pressure and volume, Boyle's law, only works if temperature doesn't change. So temperature is what? Constant. Gay-Lussac's law only works if volume is constant. And Charles only works if pressure is constant. The sad thing is, the majority of the time, something's not going to be constant. So, we came up with if you can go to a little math, a little algebra, I won't go through it, you get the combined gas law. So the combined gas law is combining all three laws together. You have P1, V1. So what law is that, P1, V1? Boyle's. Well, if we look, what happened to both pressure and volume in the other two, Gay-Lussac and Charles? What's the common denominator here? Okay, they're both doing what with temperature? Dividing by it. So we can end up with P1, V1, T1 is equal to P2, V2, T2. And so now we have a relationship between all three variables to work with if nothing is constant. Now, what don't we like about this? Division. So what can I do with it to get rid of it? Cross multiply. No big deal. So we end up with P1, V1, T2 equals P2, V2, T1. I want you to be completely honest with me and yourself. Do I need to go through and write all the different formulas? Okay. Give you that. All right. So we got P1, V1, T2 equals P2, V2, T1. Learn the process, not memorize the equations because of the formulas. So, if I'm solving for P1, all right, P1 is equal to, how do I start this out? What do I write first? All right, look at it this way. You're always going to write the other side just the way it is written. So whatever the other side is, you rewrite the exact way it's written. So P2, V2, T1. Then you ask yourself, this is for any algebra, anything in science or math. Ask yourself, each variable, V1, how is it connected to P1? Multiplication. To get rid of multiplication, I'm going to do what to it? Divide. So I'm going to divide by V1. Same question, how is T2 connected to P1? So to get rid of it, I divide. And so there is my formula for P1. Follow me? And so that means that V1 is going to be just like this. I'll rewrite the other side. P2, V2, T1 divided by P1 and T2. Good thus far? See where I'm going? It's pretty simple. And then T2 is equal to P2, V2, T1 divided by P1, V1. Okay. I'm going to be honest with you. I'm usually not honest with my students. I usually lie to them a lot. And tell you, oh, I'm not giving you any of the formulas on the test. You can memorize them all. I'm going to give you one formula on the test. I will give you P1, V1, T2 equals P2, V2, T1. It will be your responsibility, though, to be able to rearrange them to solve for each variable. But all you got to do is write the other side and then divide by what is left. So I think that's pretty fair. All right, so we're looking for P2 now. You're going to write the entire other side. P1, V1, T2. And then how is P2 connected to V2? Multiplication. How do you get rid of multiplication? Divide. Ask yourself these questions, okay? So I'm looking for P2, so it's V2 and T1. All right, then we get to V2. That'll be, again, the exact other side. P1, exactly the way it's written. T2 divided by P2, T1. And then lastly, we got T1 is equal to P1, V1, T2 divided by P2, V2. And those are your combined gas law equations. But the crazy thing is, and I want you to understand, is that I can use these for Boyle's law, for Charles' law, for Gay-Lussac's law. Because if something gets constant, what does that mean? It stays the same. So let's say temperature was 300 degrees Kelvin, T1, and 300 degrees Kelvin, T2. Well, if you get 300 Kelvin on top, 300 Kelvin on the bottom, what does that mean for T1 and T2? They cancel. And I'm left with, boom, Boyle's law. Okay? Or it just says, this is what will throw you off for a loop. They give you a problem, you got P1, you got P2, V2, V1, and it says temperature remains constant. It doesn't give you a number. Well, if temperature remains constant, it means temperature cancels in that formula. Or the volume remains constant. So volume remains constant, volume cancels. Okay? And then I'm left with Gay-Lussac's law. Or pressure cancels, and then I'm left with Charles' law. So understand, if something remains constant, it cancels out of these formulas. So all the work we've done these last couple of days with Gay-Lussac, Boyle, and Charles, that was to teach you how they change, ups and downs and things. But the math We can use combined gas law to get it. Any questions on this? We'll do a practice problem, and I'll let you go. Says initially a 22.5 liter sample of nitrogen is housed in a drum at 68 degrees Fahrenheit and 15.5 psi. What will be the new volume of gas at STP? So basically I said, hey, let me give you as much as I can in one problem and let's see what we can do with it. Because this has just about everything yet I could ever ask of you in one problem. Alright, so your first step is going to be to label everything. So you have 22.5 liter sample of nitrogen housed blah, 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 blah. So what's 22.5 liters? It's a volume. So that's my V1. Is housed in a drum at 68 degrees Fahrenheit. So what's that? Temperature. So T1. And 15.5 psi. So what is that? Pressure. And remember, these are labeled 1 not because they occurred first in the problem, but because when it was 22.5 liter sample, it was 68 degrees and 15.5 psi. Okay, they go together. What will be the new volume of gas at STP? So what does STP stand for? Standard temperature and pressure. So what is standard temperature? 25 degrees Celsius. And then standard pressure is 1 atm, 1 atmosphere. All right, we have several problems. What's our first problem? All right, temperature in Fahrenheit. Anybody off the top of their head, man, how do you get Fahrenheit? Subtract 32, multiply by 5/9. So we would have Celsius is equal to 68.0 minus 32 times 5/9 would give us Celsius. But we don't want Celsius. What do we want? Kelvin. So then after I get that answer, I'm going to add what to it? 273. And then I'm going to add 273 here also. So 68.0 minus 32 times 5/9 is what? 20. 20 plus 273 is. All right, so we got 20 plus 273 equals 293. Okay. Then 25 plus 273 is 298. So there's a couple more problems gone. Anything else need to be done? All right. I can change PSI to ATM, or I can change ATM to PSI. Which one's easier? ATM to PSI, because one ATM is equal to how much PSI? 14.7 PSI. Now, all my units are the same. Kelvin, Kelvin, PSI, PSI, and I'm looking for volume. So V2 is equal to P1, V1, T2 divided by P2, T1. So I'm going to put that in all in my calculator. P1 is 15.5 PSI times V1, 22.5 times T2, which is 298, divided by P2, 14.7 PSI, times T1, which is 293. Do we now see why it's so important to make sure everything is labeled? Plug it all in. Is that very logical? You put it all in the calculator. Make sure you put parentheses, 15.5 times 22.5 times 298, close parentheses, division symbol, open set parentheses, 14.7 times 293, close parentheses. That's what you're going to have to do it all in one step. If you do it all in one step, you should get a pretty logical answer. We're looking for volume. What did volume start at? Well, what did it start at? What number did it start at? 22.5. So we're looking somewhere around that area. And so V2, it should be, how many sig figs should be in it? I got 3 here, 3 here, 3 here. So it should be 24.1. My units would be liters. Okay, if you get some obscene number, it's probably calculator work. Because again, your calculator needs to see the parentheses here and the parentheses here, or it's going to start doing some weird stuff with your numbers. Any questions?